Hello, my name is Beth Dixon, and this is the video series based on Vicki Borlaug's PowerPoint presentation on some student activities on determining the use of distribution of individuals versus the sampling distribution of the sample means. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to create this set of videos. We have three goals from this PowerPoint that we will cover. One, to review the central limit theory. Two, to review for normally distributed data, finding a probability when one is randomly selected, and finding a probability for the mean when several are randomly selected. Notice the highlighted one and mean when several, and the two different approaches there. And then there were some student activities to review point number 2, as well as having students create their own word problems based on some given pictures. Let's start with goal number 1, which is to review the central limit theorem. This is a review of the central limit theorem. I am assuming that you have already covered the facts and the details explained for the central limit theorem, and I am just going over the highlights and the things that you'll want to remember for your test. I am not explaining the details of this. We are talking about two different distributions as we talk about the sampling distribution and the central limit theorem. One of the distributions is the distribution of the individuals. Each individual is indicated by an X, and we have the population mean, which is mu, and the population standard deviation, which is sigma. Then we have the sampling distribution of the sample means. This is where we have a distribution of the sample means that we have obtained from samples from our population. That means instead of looking at the individual data points from our population, we're looking at samples, all of the same size, and the mean of each of those samples. In this case, that then means we've labeled each mean we've obtained from each sample as X bar. So instead of dealing with X's as individual data items, we are dealing with X bar, the mean of every sample. And this sampling distribution has its own mean and its own standard deviation. The standard deviation of the sampling distribution and the mean of the sampling distribution, and the central limit theorem will give us information on that. So in brief, what does the central limit theorem tell us? And this is for an infinite population, or infinite or close enough to infinite that we can assume the following. As the sample size increases, the sampling distribution of the sample means, X bar, approaches a normal distribution. So as our sample size increases, we are getting closer to a normal distribution. Number 2, the mean of our sample distribution is equal to the population mean of our distribution of individuals. So the means are the same. And thirdly and lastly, the standard deviation of our sampling distribution of the sample means can be found by taking the standard deviation or sigma of our population and dividing by the square root of n. In other words, as you look at it, it narrows up our distribution, and therefore that means our standard deviation is smaller. And it is smaller, and we can find that smaller standard deviation by taking the population standard deviation and dividing by the square root of n. And our fact, which is if the x's are normally distributed, then the x bars, or the sample means, are normally distributed for any n, regardless of size. So if we have a normal distribution for individuals, we're good to go. But what if the individuals are not normally distributed? Then we need a large sample size. And what do we consider a large sample? Well, this would be n is greater than or equal to 30. For n greater than or equal to 30, the sampling distribution of the sample means, or x bar, can be approximated reasonably well by a normal distribution. In other words, anything larger than 30, and we're pretty much going to be close enough to a normal distribution for anything that we're doing in this course. That is our review. Now we're ready for goal number 2. Review for normally distributed data, finding the probability when one is randomly selected, and finding a probability for when the mean when several are randomly selected. We're going to go back and do a problem from a previous video, and in this case we're talking about a chef is famous for his mango flavored hard candy. Assume the temperature, called the hard crack stage, he uses to make this candy is normally distributed with a mean of 302.3 degrees and a standard deviation of 1.2 degrees. For the A part, we'll look and find the probability that if one batch of his mango flavored hard candy is randomly selected, find the probability that the temperature is greater than 301.5 degrees. And in the B part, we're going to do the same process, except in this case, we're going to be looking to see if 5 batches of his mango flavored hard candy are randomly selected, find the probability that the mean temperature is greater than 301.5 degrees. So let's concentrate on the A part first, looking at one batch. Since we're looking at one batch, we're going to use the distribution for the individual x's. So we need a mean and a standard deviation. So let's draw, since it's normally distributed, we can draw our normal curve. Place our mean in the center. The mean is 302.3 and a standard deviation of 1.2. We're looking for a temperature greater than 301.5 degrees, and greater than would be shaded to the right. We need to find the corresponding z value to 301.5, and our x is that 301.5. So z equals x minus mu over sigma, x minus the mean over the standard deviation. X is 301.5, mu is 302.3, and sigma is 1.2. Calculate that, we get negative 0.67. Look that up in the table, and our table tells you the area to the left, which would be 0.2514. That is the area to the left, and since we need the area to the right, we'll find the complement, 1 minus 0.2514, or 0.7486. So if one batch is selected, the probability that one batch selected at random will have a temperature greater than 301.5 is 0.7486. Now let's look at the B. In the B part, we have 5 batches, and we want to find the probability that their mean temperature is greater than 301. 5 batches, mean temperature. Notice the key words: something other than 1, a number other than 1, and the phrase mean temperature greater than. So we're going to be using the sampling distribution of the sample means, the x-bars. So we will need the mean of the sampling distribution, which is still equal to the mean, and the standard deviation of the sampling distribution, which is equal to the standard deviation divided by the square root of n. Again, draw your normally distributed curve and place the mean, which is still the mean, in the center. That will be the 302.3. The standard deviation of the sampling distribution will be sigma divided by the square root of n. We have to make adjustments to the standard deviation because a batch of 5 will have a mean temperature closer to the center. And since it's closer to the center, we have a smaller standard deviation. So we take 1.2 and divide by the square root of 5. That gives us 0.5367. Once you have your standard deviation, we can shade greater than 301.5. We want to find the corresponding z-value. In this case, notice it's not x equal to 301.5, but that sample mean temperature of 5 batches of candy is 301.5. And we're using the z formula, z equals x bar minus mu over sigma divided by the square root of n. It's still really the value we're talking about minus the mean over our adjusted standard deviation. So it's still really the same values. We've just adjusted the standard deviation. So we have 301.5 minus 302.3, the mean, divided by the standard deviation of 0.5367. That gives us negative 1.49. Looking up that number in our table gives us the area to the left of 0.0681. So we can mark that, and the area to the left. Since the area to the left is not what we're looking for, we'll do the complement of that and subtract from 1 to get 0.9319. That gives us our answer. The probability that 5 batches selected at random will have a mean temperature greater than 301.5 is 0.9319. Here are the exercises for you to try. Goal number 3 is to have you create your own word problems based on given pictures. So we'll go through these word problems. And I will pause here to allow me to put up the answers to the first set. Remember that the technology answers are just answers I got using the calculator. You can use your calculator to check your answers in your word problems that you've made up on your own. And remember that I can't give you the answers to those because you'll make up a variety of problems based on the pictures. Also remember that just turning in the answers to any of these that are used as quizzes will not give you full credit. Thank you for watching, and I hope this was helpful. And as always, if you need additional help, please stop by and see me in the math lab in MBSS 222.